Welcome back. In section 1.5, we'll be talking about the derivative of the inverse trigonometric functions. This is the final section of chapter 1. So we will compute the derivatives. We'll find the derivative of arctan and arcsine. We'll actually prove them too. And so we need a few results from Cal 1. So let me start by reviewing that. Here are a few results from Cal 1 that we will need in this section. So first of all, the derivative of tan, I gave it away. Do you remember what the derivative of tan is? Well, it isn't secant, but it starts with secant squared of x. Good. Derivative of sine, I'm guessing all of you remember, it's cosine. We need the chain rule here. So if I have a function inside another one, if I take the derivative of the outside, plug in the inside function, and then I need to add a term that measures how the inside function grows, and so that's going to be the derivative of the interior function. All right, so sometimes when we did implicit, we had a y instead of an x, and so it's the same thing. That y plays the role of g. So f prime of y, y prime. All right, so let me give you the derivative of arctan and arcsine, and then we'll do examples. So derivative of arctan is 1 over 1 plus x squared. Derivative of arcsine is 1 over square root of 1 minus x squared. All right, and that first one is true for all x in the domain. Second one is true for all x in the interior of the domain. Minus 1 and 1, you wouldn't find a derivative. In fact, this doesn't make sense for minus 1 and 1. All right, let's try to evaluate some derivative. This is going to be a good review as well for the derivative that you had in Cal 1. So for this term here, we have a quotient. And so since I have a fraction, I'm going to use the quotient rule. In the quotient rule, I take the derivative of the numerator and then multiply it by the denominator, and then I subtract the numerator times the derivative of the denominator. And if you remember, I had to square the denominator. All right, so this is what I have. This term is pretty straightforward. In fact, I actually wrote it here. So this is cosine. Derivative of arctan would be this function, but notice that I don't have only x inside, I have 3x inside. So for this term, I'm going to need the chain rule. So I'm going to use the chain rule with, I'm going to take y equals 3x. So I have arctan of y, so I'm going to take the derivative of arctan, and I'm going to plug in the interior function. So I'm going to plug in y, or g of x, so I'm going to plug in 3x. And then I need to multiply that by the derivative of the interior. That's this part here, g prime, so that's the derivative of 3x. And then the rest is fine. This term, arctan of 3x, we don't have anything to do. Sine, the derivative is cosine, that's fine. And then sine squared. Perfect. The only thing we have left is this. We cannot leave a derivative here. Derivative of 3x is just 3, so I get 3 over 1 plus 9x squared sine of x minus cos of x arctan of 3x. I'm not sure why. I feel it's nicer to switch the order, but it was fine the way it was, and sine squared of x. So here's the answer.